Today we're looking at 7.3. It's all about hyperbolas. So a hyperbola is basically kind of like two parabolas going in opposite directions from each other. Okay? So on this diagram of the hyperbola, we have the center. We have our first vertex, okay? And then the exact same distance from the center on the opposite side is the second vertex. The distance from the center to the vertex, that distance is A. That is A units long. We also have the focal points. The focal points are inside each part of the hyperbola. So the first focus point we can see is up here. The distance from the center to the focus point has a value of C units. So the center to the vertex is A units long. And the center to the focus points is C units. Okay. Now, notice how it makes this rectangular box. Okay. Well, you go A units from the center in either direction to get your vertices. But if you go from the center in the opposite direction, perpendicular to where you did A, the center out to this point has a value of B units. That has a value of B units. Okay. Now, down below it talks about the transverse axis and the conjugate axis. The transverse axis is kind of equivalent to what we would consider the major axis. This is the axis that goes through the vertices. The transverse axis goes through the vertices. So in this case, I have a vertex here, a vertex here. This is the transverse axis going through it. Okay. The transverse axis has a length, a total length of 2A units. The transverse axis has a total length of 2A units. A to get from the bottom vertex to the center, and A more to get from the center to the other vertex. So that's a total of 2A. The conjugate axis is the other axis. This is the one, it only goes through the center. And this one is perpendicular to the transverse axis. So it only goes through center. It is perpendicular to the transverse axis. And it has a length of 2B units. It has a length of 2B units. Over here we have the standard form of the equations for hyperbolas. The first one shows that the vertices are both on the x-axis. Right? So in this case, the transverse axis is going horizontally. That equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay? Where the center is hk. Now, if we look at the second equation actually has a typo in it, okay? The typo is in this first numerator and the second numerator. It says y minus h squared, but instead that h should actually be k. That should be y minus k squared. Over a squared minus, and then that should be x minus h squared. Over b squared equals 1. Notice this time, this is different than the ellipse. The a squared stays put. It's always going to be in the first fraction. The b squared stays put. It's always going to be in the second fraction. This time, the piece that moves is the y minus k squared and the x minus h squared. Okay? When the y minus k squared comes first, and it's over a squared, that means your hyperbola, is going to open up and down. If you look at the first one, when the x minus h squared comes first and it's over the a squared, your parabola is going to open to the left and the right. Okay? All right. Now, there's a relationship between a, b, and c. This relationship is different for the hyperbola than it is for the ellipse. This one is just like the Pythagorean theorem. C squared equals a squared plus b squared. Okay. All right, let's look at example 1. We need to graph the hyperbola that is given by the following equation. Y squared over 9 minus x squared over 25 equals 1. First, we need the center. The center of this hyperbola is 0, 0. So I'm going to start by plotting 0, 0 as the center on our graph. Next thing we need to know, is this hyperbola going to be opening left, right, or up, down? Why is it going to be up and down? Because the y squared comes first. Whatever comes first, since it's y, that means it's based off of the y-axis, so it's opening up and down. Okay, so let's put that on here. Opens up and down. Which one is a squared? Okay, a squared equals 9, therefore a equals 3. B squared then equals 25, therefore b equals 5. Okay, so from the center, I need to look at my a value. My a value is 3. This is opening up and down. So from the center, I need to go up 3 and down 3 to get each vertex. So up 3, there's my first vertex. Down 3 gives me my second vertex. The next thing we have to plot is our b value. We have a b value of 5. So, not going the same direction we just plotted our vertices, we need to go in the opposite direction from the center, 5 units, both sides. So that means from the center, we're going to go to the right 5 units. And from the center, we need to go to the left 5 units. Now, with those 4 points, we have to draw a box. And then with the box, we draw in the diagonals of the box. And with the diagonals, let's draw those all the way through the box, continuing on, and draw them as dashed lines. Okay, so there's one. And there's the other. The hyperbola always has two diagonal asymptote lines. With those asymptote lines, we can now draw the shape of the hyperbola. So from your first vertex, the hyperbola is going to come all the way out to that asymptote line without crossing it. And it's going to do that in both directions. And then with the other vertex down below, looks like my box got off a little bit. I'm going to see if I can fix that. And then the other goes upside down. So there's our hyperbola. Can I plot the focal points? Yes. What do we know about the focal points? Okay, so we know c squared equals a squared plus b squared. And the distance c units goes from the center to the focal points. So let's quickly do this. C squared equals a squared is 9 plus b squared is 25. 9 plus 25 is 34. C equals the square root of 34, which is approximately 5.83. So from the center, we need to go up and down 5.83 units because the focal points have to be just above and below each vertex. So from the center, we go up 5.83 units. There's our first focal point. And we go down 5.83 units, and there's our second focal point. Okay. Questions? Any questions? Okay, let's look at the second example. On the second example, we have x plus 1 squared over 9 minus y plus 2 squared over 17 equals 1. For this one, where's the center? Negative 1, negative 2. So negative 1, negative 2, plot the point. What is a squared? A squared is 9, therefore a equals 3. What is b squared? Therefore b equals square root of 17, and that value is approximately 4.123. Okay, so this time, which direction is the hyperbola opening? Left and right, because why? Because x comes first, and so it's based off of the x-axis. So this opens left and right. So from the center, which direction do I go for A? Left and right, 3 units. So left 3 units is one vertex. To the right 3 units is the second vertex. What do I do with the B value? Go up and down. So I need to go up about 4.123 units. And down about 4.123 units. And then we're going to draw the box. And then we need to draw the asymptote lines. Once we have the asymptote lines, then we can draw the hyperbola with one vertex opening to the right, and the other vertex opening to the left. Questions? On this one, could we also find the focal points? Yes. Okay. We've already done it on the first one. I'm not going to do that on the second one. Okay. So let's flip it over to the back. On example 3, we're going to graph the hyperbola given by the following equation. Negative x squared plus 7y squared plus 24x plus 70y equals negative 24. Well, one main difference between an ellipse and a hyperbola is in the ellipse, we're adding the two values together. In the hyperbola, we are subtracting the values. Okay? So, we look at the x squared and the y squared. I have negative x squared and I have 7y squared. So do we have one of them that's negative? Yes. And that's the x squared. So that means the x squared is going to be coming in the second fraction. Okay? So which means the y squared has to come first. So I'm going to rearrange it so that 7y squared plus 70y comes first. And then I have the minus x squared plus 24x equals the negative 24 on the other side. What do we need to do to get this in standard form? Complete the square. Can I go ahead and complete the square on the y's, or is there something I need to do first? I have to factor out the 7 first. So 7 times y squared plus 10y, and I'm going to do my plus blank. I'm going to go ahead and put on the other side equals negative 24 plus blank. Now for minus x squared plus 24x. The minus sign is actually a negative 1 that has to be factored out of those two terms, the x squared and the 24x. So I have to take out that negative 1, and then I have x squared minus 24x plus blank. And then the other side plus blank. Okay, let's look at the y's. Take 10, take half of it and square it, and that gives us 25. What have I technically added into the left-hand side of the equation? So that's 7 times 25. Now for the x's, completing the square, we look at the 24, take half of it, and square it. 144. What if we technically added in negative 1 times 144? Okay, so we have 7 times y plus 5 squared minus x, what? Nope. Minus 12 squared equals, then I have negative 24 plus 7 times 25, let's see, 175, and then negative 1 times 144 is minus 144. Okay, so 175, let's do 175 minus 144. So that gives us 31. Now 31 minus 24 is 7. Okay? Now what do I do? Divide everything by 7. Both ellipses and hyperbolas, the equation has to be set equal to 1. So our equation here is y plus 5 squared over 7 minus x minus 12 squared. Oh, no, wait. That's over 1. Excuse me. over 1. This one is over 7, and that equals 1. There's our equation. What else do we have to do? We have to graph it. Where's our center? Okay, so our center's at negative 512. Which direction is this parabola going to open up? Yes, that would be at 12, negative 5. You are correct. Thank you. Center is 12, negative 5. Okay. So now let's see. That then becomes over 12, down negative 5. Is that better? Okay. Which direction does it open? Up and down. And from the center, what is A? A is 1. So from the center, we're going to go up 1 unit and down 1 unit for the vertices. What is the value of B? Now, B squared is 7, so B is the square root of 7, which is approximately 2.65-ish. Okay, so left and right, we go about 2.6 units. Draw the box. Draw in the diagonals of the box, which are the asymptotes. And then from the vertices, we need to open it down and up. All right, questions? Then example 4. On example 4, write an equation for the hyperbola with the given characteristics. We have vertices of negative 3, negative 6, and negative 3, 2, and foci of negative 3, negative 7, and negative 3, 3. So we need to plot our points. Negative 3, negative 6, and negative 3, positive 2. The foci are at negative 3, negative 7, and negative 3, positive 3. So just by knowing that, which direction is this opening? Up and down, right? It's opening up and down. What else can we get from this? What do we need? We need the center. So where is the center located? Negative 3, comma, negative 2. Because I need to go from negative 6 up to positive 2. That's a total of 8 units long, which means the A value has to be 4. And if the A value is 4, then 4 units down from 2 puts us at negative 2. So we have a center at negative 3, negative 2. Okay. What else do we know? We know C. C is how many units? Center up to the focal point. So center to the vertex was 4, and the focal point is 1 more than that. So C equals 5. So what do we need to solve for? B and B squared. So C squared equals A squared plus B squared. C squared is 25. A squared is 16 plus B squared. 25 minus 16 is 9. 9 is B squared. Therefore, B equals 3. So from the center, we're going to go left and right 3 units. We're going to draw a rectangular box. We are going to draw in our asymptote lines. And we said this one opens up and down. And so finally, we're going to write our equation. In the equation, what has to come first? The y's. So y what? Plus 2 squared over a squared. And which one is a squared? 16. Minus, what's next? X plus 3 squared divided by what? 9 equals what? Equals 1. There's our equation for the hyperbola. Questions? Okay, last one. The last one, we have vertices at 3, 2, and 3, 6. So 3, 2, and 3, 6. And we have a conjugate axis of a length of 10 units. So if the total length of the conjugate axis is 10, what value is that really giving us? What's 5? B then is 5 units long. And if I know both of my vertices, what else is that giving me? It's giving me the center. And where's the center? Is at 3, 4. Okay. What is the length then of A? A is 2. From the center to each vertex is 2 units. Okay, so we already got the vertices, we have the center, we need to do left and right. So B to the right 5 and to the left 5. And then we draw our rectangular box. And we draw in the asymptotes. Then we can draw the hyperbola. And now we write the equation. This is opening up, it's opening up and down. So what comes first? So y what? Y minus 4 what? Divided by what? Why is it divided by 4? A is 2, so 2 squared is 4. Minus what? X minus 3 squared divided by what? And how'd you get 25? B squared, B is 5. 5 squared is 25, and that equals 1. That is the equation of our hyperbola. Any questions? All right. That's it for our notes.